Hi, I'm an old guy and I do maths, and I do hope this doesn't appear to be too scary. We have to graph this thing, and there are two or three really important things to observe here. First of all, what is it? It's the function of a quartic, which essentially looks like a quadratic graph, like a parabola, but is, shall we say, a little wider at either its maximum or its minimum. It's got a, I suppose you would say, a shallower curve to it, either at its top or its bottom. The other thing to notice is the form in which you see this. And those of you who've got to this stage in mathematics will be familiar with something like this, which is a quadratic in turning point form. Well, essentially that's what this is. This gives us the turning point of this quartic. The third thing to notice is there is a scalar factor here, dilation factor, and it's negative. So that is going to turn this thing upside down. It's going to look like that. Let's get to work. Let's do the artwork. Okay. So, first things first, let's find the maximum in this case, which is 2, 11. So 2 across and 11 up. This is not to scale, but I will put in the coordinates. Now this thing will stream off down in this direction, pass through the x-axis twice. We're going to have to work out those coordinates. We're also going to have to work out the y-intercept, which I'm going to do now. Okay, so how do I do that? Well, we start in here. If x is 0, then this is negative 2. And x will be 0 where this thing hits the y-intercept. It hits the y-axis at the y-intercept. So if x is equal to 0, this is negative 2. Negative 2 to the power of 4 is 16. Check that on a calculator if you don't believe me. Negative 2 to the power of 4 is 16. We multiply that by negative 6. Now, 3 16s are 48. 2 48s will give us 6 16s. 2 48s are 96. This is negative 96 so far. I hope you're following. So that is 16 times negative 6, which gives us negative 96, from which we we add 11, which means that we are dealing with, I think, negative 85. And so this should be 0, negative 85. But I will, just for the sake of accuracy, do this on a calculator so that you can see what we are doing. There you are. Negative 6 times negative 2 raised to the power of 4 plus 11, negative 85. This point here is 0, negative 85. And so what happens is this thing comes down here, passes through the x-axis here, and heads on down, passes through the y-axis here, and carries on to negative infinity. And a corresponding and symmetrical arm of this quartic does the same thing. So we are now left trying to find these 2 points. which will be equidistant from 2 on the x-axis, because this thing is symmetrical. This has an axis of symmetry. Okay, so how do we find those points? Well, that's where this gets interesting. What we have to do is make some room here. We have to make -6 into x minus 2 to the power of 4 plus 11 equals 0. It equals 0 here and here. We should get, and we will get, two answers to this. So let's go to work. -6 x minus 2 to the 4 equals -11. X minus 2 to the power of 4 equals -11 over -6, which is 11 over 6. That's positive. And oh my, we're going to take the 4th root of each side, and that's really going to be exciting. So x minus 2 is equal to the 4th root of 11 over 6. Now, this can be positive or negative. This is a positive number, so the 4th root of it, I need to put a 4 up there. I hope this isn't too crowded. That's 4, that's plus, that's minus. This thing has two solutions. So x is going to equal 2 plus or minus the 4th root, I give myself some room here, of 11 over 6. So we start here and we move 11 over 6 to this point, which is somewhere close to 4, but it's not 4. So this point is 2 plus the 4th root of 11 over 6, 0. And this point here is, I'll put an arrow in here and write this up here, 2 minus the 4th root of 11 over 6, 0. Those are our points, and this is how we got these. Now, this was given to you. This was given to you in a form in which it's really easy to work on. So when you see something like this, just be thankful, because you could have been given the expanded form of this, which would take work, but it could be solved without extraordinary difficulty. But these points of intersection here would be somewhat difficult to find, I imagine. Anyway, that is how you graph this thing. Those are the steps. The easy one, the next easiest one, and the ones that take a little bit of work. But those of you who are used to dealing with quadratics will see that there are some real similarities here. We're just dealing with 4th powers and 4th roots rather than squares and square roots. Anyway, thank you very much for watching. I do hope you found that useful. If you did, please like and subscribe, and I will see you next time. Bye.